Complete electronic configuration. How to place electrons in subshells and orbitals. I challenge you that you will not find this type of simple explanation in the whole YouTube community. Also, we will discuss the common problems of students. So watch this lecture till the end and you will learn something awesome. Firstly, let me teach you some key concepts like subshells and orbitals. We know that there are 4 different subshells like SPDF. Remember that we represent subshells by azimuthal quantum number L. For example, when L is equal to 0, it is S subshell. When L is equal to 1, it is P subshell. When L is equal to 2, it is D subshell. When L is equal to 3, it is F subshell. Now what about the electrons of subshell? Well, I write it 2 electrons and then I add 4 electrons successively. 2 plus 4 is equal to 6. 6 plus 4 is equal to 10. 10 plus 4 is equal to 14. So S can accommodate 2 electrons, P can accommodate 6 electrons, D can accommodate 10 electrons, and F can accommodate 14 electrons. On the other hand, every subshell has degenerate orbitals. For example, S subshell has 1 degenerate orbital, P subshell has 3 degenerate orbitals, D subshell has 5 degenerate orbitals, and F subshell has 7 degenerate orbitals. The simple trick is to divide the number of electrons of subshell by 2, and you will get the number of orbitals. For example, dividing 2 electrons by 2, we get 1 orbital. 6 electrons by 2, we get 3 orbitals. 10 electrons by 2, we get 5 orbitals. 14 electrons by 2, we get 7 orbitals. Now what about the main shells of atom? We know that main shell are represented by principal quantum number. For example, when n is equal to 1, it is K shell. When n is equal to 2, it is L shell. When n is equal to 3, it is M shell. When n is equal to 4, it is N shell. Secondly, we know that every shell has subshells. Now how can we learn the subshells of main shells? Well, I teach this trick. I write here S and I add 1 subshell successively like S, SP, then SPD, then SPDF. This is S subshell, belongs to first shell. I write here 1. These are SP subshells. They belong to second shell. I write here 2 and 2. These SPDF subshells belong to third shell. I write here 3, 3 and 3. These SPDF shells belongs to fourth shell. I write here 4, 4, 4 and 4. Remember that this 1s is different from 2s. This 1s means it is the subshell of first main shell. And this 2s means it is the subshell of second shell. So remember that 1, 2, 3, 4 with SPDF represents the main shells. Let me repeat it. These numbers 1, 2, 3, 4 with SPDF subshells represents the main shells. Now what about their orbitals? Well, this 1s has 1 orbital, this 2s has 1 orbital, this 2p has 3 orbitals. Similarly, this 3s has 1 orbital, 3d has 5 orbitals, this 4s has 1 orbital, this 4p has 3 orbitals, this 4d has 5 orbitals, and this 4f has 7 orbitals. Thus note down this complete concept of shells, subshells and orbitals. Now we will discuss the first problem and its solution. I mean, how can we place electrons in the subshells? Well, consider nitrogen atom. We know that its atomic number is 7. Now the problem is, how can we accommodate the 7 electrons in subshells? Here comes the Aufbau principle. Aufbau principle teaches us about filling subshells. Aufbau principle states that electrons fill lower energy subshells before filling higher energy subshells. Let me repeat it. Electrons fill lower energy subshells before filling higher energy subshells. Now here students do a lot of mistakes and they face big problems. I mean, they cannot remember the order of subshells from lower to higher energy level. So to solve this problem, I teach this easy trick. I write SPDF and I write 1, 2, 3, 4. I go from back side. I write here S 2 times, S and S. Then I go from P to S. I write here 2 times, PS and PS. Then I go from D to P to S. I write them 2 times, DPS and DPS. Lastly, I go from F to P to D to S. I write them 2 times, FDPS and FDPS. We know that S is the first subshell. I will start numbering the S subshell from 1, like 1S, 2S, 3S, 4S, 5S, 6S, 7S and 8S. Secondly, the P is the second subshell. I will start numbering the P subshell from 2, like 2P, 3P, 4P, 5P, 6P and 7P. Thirdly, the D is the third subshell. I will start numbering the D subshell from 3, like 3D, 4D, 5D and 6D. Lastly, the F is the fourth subshell. The F subshells by 4, like 4F and 5F. This is the order of increasing subshell. Now consider chlorine atom and its atomic number is 17. We already learned that S can accommodate 2 electrons, P can accommodate 6 electrons, D can accommodate 10 electrons, F can accommodate 14 electrons. In case of chlorine, 2 electrons are placed in 1s, 2 electrons in 2s, 6 electrons in 2p, 2 electrons in 3s, and 5 electrons in 3p. This is the complete electronic configuration of chlorine and subshells. Thus we learn that Aufbau principle teaches us about filling subshells with the electrons, and we use this easy trick. Now we will discuss the second problem. I mean, how can we place electrons in orbitals? Well, to solve this problem, we use the Hund's rule and Pauli exclusion principle. Pauli exclusion principle states that each orbital of a subshell can accommodate 2 electrons with opposite spin. For example, consider this 1s orbital. It will accommodate 2 electrons, but the spin of electron must be opposite. Secondly, Hund's rule is all about filling orbitals of subshells. I always teach these 2 important points about Hund's rule. Firstly, it states that every orbital is singly filled before any orbital is doubly filled. For example, consider this 2p orbital. I am interested to place 6 electrons in it. Firstly, I singly fill it. 1 electron, 1 electron, 1 electron. Then I doubly fill it. 1 electron, 1 electron and 1 electron. So I successfully placed 6 electrons and 2 orbitals. Secondly, it states that all electrons in singly filled orbitals have the same spin. For example, consider 2p orbitals. I am interested to place 3 electrons in it. I place first electron in upward direction, the second electron in upward direction, and the third electron in upward direction. Or we can place these 3 electrons in downward direction. So here, all the singly filled orbitals have the same spin. So these both cases are correct. Now we will discuss some common mistakes of students like these. This is wrong because according to Hund's rule, firstly, we have to singly fill it. I write 1 electron, second electron and third electron in upward direction, or first electron, second electron and third electron in downward direction. These both cases are correct. Secondly, it is wrong because according to Pauli exclusion principle, their spin must be opposite. I need to correct the spin. first electron in upward direction and second electron in downward direction. This is correct. Thirdly, it is wrong because according to Hund's rule, we have to singly fill it, like first electron and second electron in upward direction. Finally, this is also wrong because these all electrons have the same spin. I write first electron, second electron, third electron in upward direction, then first electron, second electron and third electron in downward direction. Now it is correct. Thus noted down these common mistakes of the students. Finally, to summarize this whole lecture, let me ask you, configure the electrons of oxygen in subshells and orbitals. Pause the video and try to solve it. Well, I write SPDF and 1, 2, 3. I go from back side. I write here S 2 times. S and S. Then I go from P to S. I write here 2 times PS and PS. I start numbering S subshell 1, 2, 3, 4. I start numbering P subshell 2 and 3. We know that oxygen has 8 electrons. I place 2 electrons in 1s, 2 electrons in 2s, 6 electrons in 2p. Secondly, 1s has 1 orbital, 2s has also 1 orbital, and 2p has 3 orbitals. In 1s, first electron in upward direction, second electron in downward direction. In 2s, first electron in upward direction, second electron in downward direction. In 2p, I write first electron, second electron and third electron in upward direction, then first electron in downward direction. So this is the complete electronic configuration of oxygen in subshells and orbitals. Thus noted down this important example. I hope that you have learned the complete electronic configuration.